Welcome back to this channel with practice problems for professional actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. You have some information about my video channel and where you can sign up for the online seminars that I teach, as well as study manuals for exams P, FM, MLC, and MFE that I authored. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help ISU Actuary. Here's a problem for today. This was also my online exercise posted previously in a PDF file on September 6, 2008, but now this will be a video. A manufacturer's annual losses follow a distribution with density function f sub x of x equal to 2.5 times 0.6 to the power 0.5 divided by x to the power 3.5 for x greater than 0.6, and the density is 0 otherwise. To cover its losses, the manufacturer purchases an insurance policy with an annual deductible of 2. What is the mean of the manufacturer's annual losses not paid by the insurance policy? And here's the solution. Let us write y for the manufacturer's retained annual losses. And I'm saying retained because you could think about the manufacturer being a primary insurer for the losses, and then the insurance company being like a reinsurance company. Then the retained losses are equal to x for x between 0.6 and 2, and 2 for x more than 2. Now, the reason why it's x more than 0.6 is because for the values less than 0.6, the probability is 0. That's how the density is constructed. And then, of course, less than or equal to 2, that just refers to the deductible of 2. Until the loss reaches the deductible, everything is paid by the manufacturer. And then beyond that, the manufacturer pays 2, and the insurance company pays x minus 2. Well, given this, we are asked to find the expected value of y, and that's equal to the integral from 0.6 to x, to 0.6 to 2 of x times the density dx, plus the integral from 2 to plus infinity of 2 times the density dx. Because that's what we have. It's x for the first interval and 2 for the second one, and we just multiply by the density in either case to find the expected value. So the first integral is the integral from 0.6 to 2 of 2.5 times 0.6 to the power 2.5 divided by x to the power 2.5, because it's x to the first divided by x to the 3.5, so it becomes 1 over x to the 2.5. And the second is the integral from 2 to plus infinity of 2 times 2.5 is 5, and then 0.6 to the 0.25, the whole thing divided by 3.5 dx. So the integral of the first function is 2.5 times 0.6 to the power 2.5 divided by 1.5 times x to the 1.5, but with a minus sign in front, because this is x to the negative 2.5 power. That's actually a derivative of minus 1 over 1.5 to the times x to the power negative 1.5. And if you take the derivative of x to the 1.5, x to the negative 1.5, you'll get negative 1.5, which will cancel with this negative 1 over 1.5 times x to the power negative 1.5 minus 1, which is x to the negative 2.5. And then for the second integral, well, that would be minus 1 over 2.5 times x to the negative 2.5. But of course, 5 divided by 2.5 is just 2. That's where we get that. Times 0.6 to the power 2.5. And we evaluate the first integral from 0.6 to 2 and the second one from 2 to plus infinity. So of course the second one at plus infinity is 0. You can see that immediately. But otherwise we just plug in the values. At 2, x to the 1.5 becomes 2 to the 1.5. And when x is equal to 0.6, then we have 0.6 to the 1.5, but at the top we have 0.6 to the 2.5. They cancel out. It's just 2. It becomes 0.6. And we subtract that, but there's a minus sign there, so it becomes a plus. And then the other quantity, as I said just a moment ago, at infinity, that's 0. And if we plug in 2, we get 2 times 0.6 to the 2.5 over 2 to the 2.5. But of course, 2 divided by 2 to the 2.5 is just 1 over 2 to the 1.5 power. And now we just calculate all these, and we get approximately 0.9342733. So you might wonder why I'm not using the Darth Vader rule. Well, actually, you can solve this using the Darth Vader rule. We could also solve this problem by noting that the payment by the manufacturer for the retained losses is equivalent to a policy with a limit of 2. So the manufacturer acts as an insurer for the losses and issues a policy with a limit of 2. And if that's the case, we can find the expected payment for retained losses by taking the integral from 0 to 2 of the survival function of the random variable describing the losses. Well, what is that survival function? It's equal to 1 for x between 0 and 0.6, because losses are not possible in those amounts. And then it becomes the integral from x to plus infinity of the density that we have, which is 2.5 times 0.6 to the 2.5 over t to the 3.5. I'm using t because x is used for one of the limits of the integral, dt, for x more than 0.6. So we take the integral of this function that we have there. We get simply minus 0.6 to the 2.5 over t to the 2.5, evaluated from t equal to x to t going to plus infinity. And so the survival function is calculated to be 1 for x between 0 and 0.6, and then 0.6 to the 2.5 over x to the 2.5 for x more than 0.6. Well, then the expected value is just the integral from 0 to 2. And the reason why it's from 0 to 2, not 0 to plus infinity, it's because there's a policy limit of 2. That's where it comes from. So it's the integral from 0 to 2 of the survival function. And then we see that from 0 to 0.6, it's just the integral of 1, which is 0.6. And then beyond that, it's the integral from 0.6 to 2 of 0.6 to the 2.5 over x to the 2.5 dx. And the integral of that function is, well, it's negative 1 over 1.5 times x to the negative 1.5 times 0.6 to the 2.5. And I just separated the negative 2/3 because 1 over 1.5 is 1 over 3/2, so it's 2/3. We evaluated from 0.6 to 2, and so this becomes 0.6 minus 2/3 times 0.6 to the 2.5 over 2 to the 1.5 minus 0.6 to the 2.5 over 0.6 to the 1.5. And 2/3 times 0.6, that's the same as 2 times 0.2, so that's 0.4, and it will have minus minus, so a plus sign, while the first expression will become, well, the one of the 2's will cancel out. So 2 divided by 2 to the 1.5 will just become 2 to the 0.5, which is square root of 2, and the top remains 0.6 to the 2.5, and then 3 stays in its place. And otherwise, we just calculate this, and it comes out to be exactly the same number as before, 0.9342, 733. So this is the same answer as before, but this time obtained with the Darth Vader rule for an insurance policy covering a loss with a policy limit. And this is answer choice C. Please remember this is copyrighted material. The problem itself comes from a Society of Actuaries, but the solution is mine. Good luck in your studies and good luck on the test.